So guys, so far we have studied and we have completed 4 different sessions. So on my screen, you can see, so I'll go on to the my purchases, and if you click on this SolidWorks, here are all the sessions like day 1 completed, day 2 completed, day 3 completed, day 4 also completed, and we also completed day 5, right? So these are all the sessions we already completed. Not day 5 right now. The day 5 session is happening at this moment. SolidWorks Assembly Basics. So here is this session that we are live right now. So from your dashboard, you can join the class daily. And for first 3 days, the recorded sessions are already live. Like if you want to check out, you can just go into your dashboard and you can check it out. For the day 4 session, we have not uploaded so far. The yesterday session, we have little bit of problem. So we'll be uploading very soon. So just be updated. Once we'll finish uploading, we'll let you know into our WhatsApp group. So, okay, so Abhijit is asking where we found extrude after drawing a sketch in assembly. This is very, very basic question. But still, I'm happy that if you are trying, you will see problems like this. And this should be discussed. And this should be discussed, problems like this, into the live sessions only. So, where we found extrude after drawing a sketch in assembly. So, let me start up any part first so I can give you the demo. Abhijit, listen it carefully. So let's say you are working on a sketch. So I will go on to the sketch. So let's say I'm working on a sketch, right? And if I want to extrude this sketch to convert this to 3D, we have to go to the feature tool panel onto the top, right? And there is a tool called extrude. But this tool is not active at this moment. Why? Because right now we are active inside a sketchwork environment, and first once we are done with all the sketching, like adding dimensions and everything, we have to click on this button that will exit this sketchwork environment. And once we'll click on this button, I can see under the feature tab, this tool just became activated, right? So from here you can access this tool. Very simple, right? So, but in this video, we are here to learn what is assembly, how we can join multiple parts inside SolidWorks, inside assembly files, right? So first, as I told you, whenever you save a part, it saves with a file extension of .sldprt. In the similar manner, if we'll create an assembly file, and that you can create from the same file, just go into this file, click on the new, and then from here you can start assembly file. And once you will start assembly file, this file will get saved as the extension .sldasm. I hope everyone knows about it. .sldasm is the assembly file format inside SolidWorks. So if I will start this assembly file and will press OK, and the moment I will launch assembly file, new assembly file. So right now this file comes with a default name over here, right? Right now it has a default name, ASM1. We'll change this. For that, we'll click on here and we'll click on save to this PC. And then onto my desktop, I will save it inside the assembly folder. And the moment I will click on save, in the name itself, you can see the extension just got added. That is .sldasm. So whenever you will see a part like this, a file name like this, you can directly come to a decision that this file is an assembly file of SolidWorks. So if you are in design industry and if you join a company and you get a chance to explore the files on the PC or laptop, and wherever you find the parts like this, like SLDASM, SLDPRT, so you can directly estimate that these files are being created inside SolidWorks only. So I will first save this one. And the moment I save this one, you can see the extension just got added, assembly1.sldasm. So always remember the file format, the file extension, the file name extension for assembly file inside SolidWorks is .sldasm, and for part file, it's SLDPRT. I hope it's clear to you. Now, what is assembly? How it is different from part, right? So normally we used to create parts inside SolidWorks. If I'll go on to my home tab, you can see these are all part files I have created inside SolidWorks. This, and this. Here you can see the history, right? So whenever you use any software, you can see the history, like what is the last file that you have opened. So from here we can see we have worked on these part files and how it is different from assembly. So let me open a simple assembly for you. File, open. I will open a simple assembly for you so you can have an idea what is the difference between part file and assembly file. So here we have a simple assembly file. I will open it. Simple assembly file, the project we were working on right now. So I will click on rebuild. So here is the assembly file that you can see on your screen right now. How it is different from part file, you can see over here. So normally in part file, what happens, it has single part, right? Or it has a single component, we can say, not single part, single component inside a part file. But assembly.sldasm is the mixture of multiple component, could be mixture of multiple component, or assembly could also be a just one component as well. But part file always be of single body or multiple bodies, right? That's the difference. For example, these are all the part files. So by including these part files, we had created this assembly, and inside this assembly we had like placed all the components into their orientation, and that's why I call this assembly file. That is the difference between assembly file and part file, the basic difference. Anyone have any questions? Let me know into the chat box. If you have any questions, just let me know into the chat box. Is it clear to everyone what is assembly, difference between part and assembly? If it's clear, just write Y into the chat box. Just write Y. Everyone, I can see there are so many participants now. Just write Y into the chat box. Thank you. So, thank you. Okay,
Sir,
so
just
guys,
revision for one time, sir.
yes.
Just revision for one time, sir. Simple, simpler revision.
So I was talking about the difference between assembly and part file. What is part file and what is assembly file? So right now on your screen you can see it's an assembly file that comes with an file extension of .sldasm. So whenever you will save this file, this complete file, it will get saved as a .sldasm, right? Whereas your part files, if I'll open any part file, for example, if I'll open this one, the one that we did in the last session. So this is a single part file, and part file always saved with a file extension of .sldprt, right? And when we include multiple part files into a file, that is known as SolidWorks Assembly. So this is what you can see over here. It's a mixture of multiple part files. So this is the one part, this is the another part, this is the another part, and this is the another part. So we have almost 4 part into this complete assembly, and that's the basic difference between assembly file and part file. And always you can check the file extension, right? Now every part file inside SolidWorks, so if we'll go back to a part file inside SolidWorks, you can see this is a part file, right? Now it has only single component, it doesn't have multiple components, and we cannot insert multiple components into a part file, right? It's not possible. We can create multiple bodies. So if you'll see the design tree, there is a folder called solid body, and if I'll expand that, you can see there is a single body, right? So there could be multiple bodies also. If I'll split this body into multiple parts, there could be multiple bodies, but there could be only single component. So if this is a component, we can say it. So inside part file, we only have a single component. But if we'll go back to the assembly file, we can have multiple components, right? Now, the top label that you can see, I had given a name called benchwise. In the top level of design tree, I had given this name benchwise. So this is called as father, right? And this is the father, that is also known as assembly, whereas these are all the childs of this father. All these part file are child of this father, right? So this is the difference between SolidWorks part file and assembly. I hope it's clear to everyone. Now, when to use assembly, when we can use assembly, right? So whenever you are working in a SolidWorks and if you want to create a single part only, for example, I just want to create a nut, right? Or I just want to create a bolt. So those are just single part, right? In that case, we can simply create nut or bolt separately as a part, right? But when we want to show someone how the things will fit together or whether they are uh, good inside, so they can fit together, whether they are compatible or not. For that purpose, we can use the assembly file in that case. For example, let's say I'm building a machine. Let's take an example of this one. This one you everyone know, right? What it is? It's a Rubik cube, right? We call it, and it has multiple parts. If you remember, it has corner parts, middle parts, then again corner parts, and like that, it has almost how many parts? 27 parts, right? It has 27 parts and a center part that is holding all the pieces together. So there are total 28 parts. So if I will just take this corner piece of this Rubik cube and show that in SolidWorks, design that in SolidWorks, that will act as a part file. But once we'll take multiple part file and show assembly like this inside SolidWorks, that will known as a SolidWorks assembly file, right? And when we use assembly file, when we wanted to show someone like how the parts will fit together, right? In which orientation the parts will fit together. So in that case, we always have to use the assembly. We have to show the SolidWorks assembly, right? So this is the basic difference. Now, I will show you from the very basics, from the very start, how we can start a new assembly and how we can start inserting the part into it. We had a little bit of kind of demo in the last session, but I will again repeat it from the very basics. So in that complete process, if you got any questions in the middle of it or anywhere at this complete session, just write that question into the chat box, so you query into the chat box. So first I will close this part. Now for this complete demo, I have prepared a very simple part files. So that we're going to use that. But before, I will close everything, right? Everything I will close. Now this is the screen whenever you will launch your SolidWorks, and let's say you finished modeling all the part files. Now you have to make an assembly of by using those part files, right? So how we'll do that? Go to the file menu and click on new, right? For this, we can also use the keyboard shortcut Control+N to launch this command, right? But here I will simply use my mouse. I will launch this new, and there you will see option to create part file that let's say we have already created multiple parts. So we are not going to use this. To start assembly file, we'll select this option, the middle option, always. Simply select it. You can see it's getting highlighted. Once you selected it, press OK. A new file will get launched with different set of tools. So whenever you are working in part file, if you remember, the first tool panel was not assembly. The first tool panel was, can anyone write into the comment what was that first tool panel that you will be able to see whenever you are working inside part file? What was that? Just write into the chat box. What was the first panel when we were working in as a part file inside SolidWorks? What was the first tool panel you were able to see? Just write into the chat box. I'm waiting. Anyone? If you don't know, just write N into the chat box. I will show you. If you don't know what was the first tool panel, just write N into the chat box. I will show you what was that. But okay, that was not a sketch. Okay, so that was not a sketch. If you remember, let's start a part file also. So I will again click on new, start the part file. So that was features. The first tool panel was features, and under which you were able to find extrude and everything, right? But in case of assembly, the first tool panel we see is assembly only, assembly itself, right? So whenever you launch assembly file, you will be able to see this option assembly tool panel. So from this, it also you can estimate like what kind of file it is. So we have launched the assembly file. The first thing we'll do, we'll save it first. We'll click on the save and we'll save it a new name. Let's save it onto desktop this time, onto this assembly file. I can write assembly 2 because assembly 1 is already there. So we cannot use that same name. So we'll write assembly 2, right? .sldasm. I will click on save. So you can see that file just got saved. Now the next important thing, as always, make sure that your units are correct. System of units at the bottom right corner. Here it is millimeter gram second. So this is what we're going to use. And just let me check if our recording is turned on. Yes, our recording is turned on. So we just so where was we? So we just activated this assembly file. We set up the right system of units. Right now in this assembly file, we have to bring the first component. Right now, this assembly file is completely empty. So to bring the first component, we'll go on to the assembly tool panel, and there you will find a tool called insert components. Right. So by using this tool, we can insert our first component into our assembly file, because assembly is the mixture of or made out of multiple components. Right. So first we have to start from the first one. So we'll click on this insert component, and the moment you will click, it will redirect to your PC to find the file that you want to insert. So in this case, I will use this part 1 file first. So I will insert this part 1 file first. So I will select the file, I will click on open, and the moment you will click on open, I'm not touching anything, you can see that. But with your cursor, you will be able to see a part is attached that you just inserted, right? You can move it until and unless you will click anywhere, it is attached with your cursor. But before placing it, I can zoom in and zoom out. I can also rotate it in multiple orientation along all the 3 axes to reorient it in a correct position, right? So I can rotate it like this using these gizmos, or even I can change the angle to change the rotation. Like let's say I want to rotate at 0 degree. So I can rotate it accordingly, not 0, let's make it 180. So if I make it 180 here, and if I rotate it, it will directly rotate 180 degree. There you can see. So we'll keep the default over here as 90. So we can see the rotations, right? So this way you can rotate your part. Now, before placing it onto your assembly file, just go into this option. With these options, these settings just turned on, just go into this option of this view drop down and turn on these 2 options. So these are for the axis coordinate systems. So the moment you will turn on these 2 options, and if you'll click again to hide it, and then you can see 2 axes, right? 2 origins. One is attached with the body and one is onto the center of your screen, right? That is inside this assembly file. So how you can place it? Simply move your cursor. You have to focus on your cursor. Move your cursor near to this origin, and automatically it will snap onto the point like this. So here you can see whenever I try to move into the cursor, automatically both the origins of this body and of this assembly file is getting aligned, coincident, right? Here you can see like this. And once you see the result like this, coincident on the same point, make a click to place it. So here you can see what I did. While placing this component into the assembly file, I made sure that the origin point of the body, origin point for the component, and also for this assembly files are aligned, are at the same point. So whenever you're doing for the first component, you have to make sure you had followed this step, right? And why? Because whenever you create any part file, so if you'll remember, if I'll go on to the home, if I start any part file, let's say this one. So if this is our part file, right? So every part file have their origin. So this is its origin. Here you can see. So every part file have their origins also. And whenever we insert this part file into assembly, the origin also goes with it. So we have to make sure that the origin of the part and origin of the assembly should align at a single point for the first part, right? Let's move back to the assembly file now. In this case, right? So we have placed our first part. Now still, if you'll notice the design tree, you can see this is our first part file we inserted, but just before that, can you see this small minus icon inside the bracket? This means this part is still free to move inside this workspace. So if I click on this part, any face, and drag it around the space, you can see we can move it. Why? Because this part is not, I will press Ctrl Z to bring it back. So this part is not fixed inside the space. So first thing I will do, I will make a right click onto the component or the part and will click on fix. And the moment I will click on fix here, you can see the icon change to F now, and this part is fixed. And why we had made it fixed? Because if you want to assemble multiple components, let's say for example this one, this assembly, if you want to assemble all the pieces together, you have to hold at least one piece, then only you will be able to insert the other part into it, right? If we'll make it free, the first part, and if we'll try to insert something, you will not be able to insert, right? It will move with the part as well. That's why, to make this assembly stable, we had fixed the first part, and that is the way to start an assembly. Like, this is the approach to start an assembly. Any questions up to this point, guys? Let me know into the chat box. Anyone have any questions? Or else write N into the chat box. Write N into the chat box if you don't have any questions. Just write N into the chat box if you don't have any questions. Okay, so this is the first part we had inserted. Now we are done with the first part. Now let's move and insert the second part. So again, we'll go onto the assembly tool panel. We'll click on the same insert panel. So yes, that's a very good question. So once you have inserted this first part and fixed it, you cannot change the orientation. So to change the orientation, what you have to do, make a right click and first click on float. So basically unfix. So float is a new name of unfix. So first what you have to do, click on float. So now it is again free to move. Here you can see, I will press Ctrl Z. So once it is again free to move inside the space, then you can use there are tools called move. So we have to find that tool. I cannot see it, so I will find inside the command panel this move component, right? I will keep this into my tool panel, right? So here you can see, so whenever you inserted the part, placed it, and now if you want to move, you have to use this tool called move component, and then you can activate the tool, and then you can drag your part, and if you change the option over here, like if you want to control it along XYZ position using these values like -50, apply, you can see it's moving. So this way you can do that, but that's more harder than doing it in the beginning, right? So using the move tool is not very easy. It is so complex. So I always recommend, like, either you decide like in which orientation you have to place, and if anyhow you place it somehow in a wrong orientation, your first part, just press Ctrl Z and start the assembly from the start, right? That is the best way, I think. Otherwise, the moving your component, or even if you want to move your component, or even if you want to pan it or rotate it, you have to use these tools called rotate component, move component, and by make it floating, you can perform these operations. Because once this is fixed, you cannot move these tools. See, I cannot move it, right? I cannot move it. So if I want to move it or rotate this component in a certain orientation, we have to make sure that this is not fixed, this is floating, right? And also, after placing and aligning the origin, if you want to move it and rotate it, your origins will get displaced, right? And why origins are important, we'll show you in a moment, right? So here is the first part we inserted. Now let's insert the next part. Same process, go to the assembly tool panel, click on insert component, right? And then click on browse to browse your next part. And let's say I want to insert this part 2 now. So I will select the part 2. I will click on open. Okay. So here you can see we are going to insert this next part, and the moment we inserted this next part using this browse feature into SolidWorks, you can see the orientation is not right. We want to keep this slot, semicircle slot that you can see into this new part towards the top. So first we have to reorient this part. So we'll use these gizmos to reorient it, right? We can rotate it and we'll see like this, which works best. So accordingly, we have to rotate like this. So we'll see. Yes. So this is the orientation we want to keep, and we want to place this into this slot. We want to place this part into this slot. So what I will do first, I will reorient it in the correct orientation. And once done, I will simply place it anywhere onto the screen near to this area, right? Just by clicking, right? So here you can see I had placed it somewhere over here now. So we have inserted our part 2. Let's insert our next part, that is part 3. Again, I will go on to the assembly tool panel and will click on this insert component, right? And then we'll click on this browse and we'll find the next part, that is the part 3. So this was the third part that I want to insert. Again, I want to insert this part into this slot, but again, the orientation is not right. So maybe we have to rotate it. And how you can find that in which direction you have to rotate? Like if you try to do these things randomly, that is going to waste time, right? So that you can estimate. You'll see at the bottom corner, all the axes are defined, right? The Z is pointing towards upward, X is towards forward, and Y is towards left side. So if I want to rotate this part in correct orientation, we have to first rotate it towards using this Z gizmo. So here you can see, maybe if I rotate 2 times, this is the orientation in which we want to place. So I will, since the orientation is correct now, I will simply go near to that area and will click. So it will get placed somewhere near to that area, right? So now we are done with inserting all the components into this assembly. And also we had fixed the base component, that is the main component or the first component. Now is the time to start applying the assembly commands between all these components. And for that, let me just check. And for that, there is a tool called Mate inside SolidWorks. To apply all kinds of assembly, there is this single tool only inside SolidWorks to do all kind of assembly, simple assembly, advanced assembly, anything. This one tool called Mate. So what I will do, I will activate this tool. I will click on it. So tool just got activated. Here you can see tool just got activated. Now if in the first option, it is asking me to select the Mate selection. So the assemblies can only be done using the faces of your body. For example, if first I want this face of this body, this face of this body, I want to be aligned with this face, right? So first what I will do, I will click on this face after activating the tool. Here you can see the face one got selected. Now I will orbit it like this and will click on this face. So here you can see the body just got aligned. I will click on this finish, and now you can see this body is just got constrained along that face. So if I'll see you from the if I'll show you from the top, we'll try to move it. I'm only being able to move along that face only. Here you can see I'm only be able to move along that face only. So now that face is touching this face all the time, and this face and this face, both of them considering them as infinite planes. So that's why they are able to move anywhere along that plane, right? But they are constrained with these faces. Now to make this body fit, we also have to define that this face, right, this face and this face should also touch, right? Or first we'll define the top faces to be on a same label. So for that, we'll again activate the mate tool, right? Here you can see mate tool is active. We'll select the top face of this one, then this one, and you can see both of them just got aligned. I will click on finish, right? So now my part is constrained with reference to that horizontal and the top face, but still I can rotate it because the third constraint we have to apply this face and this face. So again, we'll select this face and this face, and now you can see the body is in the right position. So if I click on finish, you can see we just assembled these two parts perfectly in a right slot, right? And the moment I will click on finish, in the design tree, you can see a fourth new folder just got added with the name mates, right? So if you'll expand the mates, you can see these are the three. If you'll move my cursor onto the command, you can see these are the three constraints we have applied. So the first one was between those two faces. You can see the face is getting highlighted. The second one was between these two faces, the top faces, and the third constraint we applied on these side faces, and that's why our body is constrained, right? So this was one of the very simple assembly. Now let's do the same for these two areas, right? I want this to be assembled into this region. So again, we'll activate the mate tool, right? We'll select this cylindrical face and this cylindrical face, and here you can see both of them just got aligned. I will click on finish. Now I also want this face to be touching that face, right? So for that, the tool is still active. You can see the mate selections. I will click on this face and this face. So it got moved. I will click on finish. So now this is also, we have applied the assembly. Now if you click on finish, under the mates folder, you can see we had applied the concentric constraint first between both the cylindrical faces, and then we applied this face matching constraint or the mate type, right? So this is how we had assembled these three pieces together. And for all the pieces that we used over here, all three pieces have their separate origins that you can see. So to make this drawing or view more clear, I will turn off these origins, right? Here you can see like this. I can turn off the origins. Okay, so let me know any questions, guys. If you have any questions up to this point, just let me know. Okay, so you can see we have assembled the parts together. Now we cannot move these parts. Here you can see we can rotate this part over here. So definitely there is a revolute kind of mate between these two pieces, but here this part we cannot rotate or move. Why? Because when we mated this component and this component, we had applied three mates, right? And because of the three directional mates X, Y, and G, these parts became completely rigid kind of joint, right? So in this case, the assembly between these two parts are, we can say, rigid, right? But in this case, the assembly between these two parts are, we can say, revolute, where this cylindrical part can rotate into the cylindrical slot. So now let's move on to the next thing. So the first mate, if you remember, the first mate we have applied was coincident, where we have made sure that the end face of this part was aligning with the slot and the face part of that part, right? So let's change something. So we'll go back to our design tree, and under the mates option, we'll find the mate that we want to modify. So we'll click on it, we'll make a right click, and we'll click on edit mate, edit feature, right? I will click on edit feature. And the moment I will click on edit feature, here you can see this is the mate we have applied, right? Between two faces, right? And that was coincident. We have applied a coincident kind of face, this one. Now, if you'll move to the bottom, can you see this option that says distance, right? Let's say I want to apply this mate, but I want to keep a certain kind of distance between these two faces. So I will simply click on this distance, right? And then we'll enter some values. Let's say I want to keep a distance of 5 millimeter. So I will write 5 and will click anywhere outside that box and you can see that part just got moved by 5 millimeter. So now we are mating this part with this, but we are also keeping a 5 mm of distance between these two faces, right? Let's make it a little bit higher, maybe 10. And if you click outside anywhere, then here you can see the parts are getting adjusted. Now if I'll click on finish, so what we did, we had modified this mate. Now still it is rigid kind of joint, but a distance between this face and this face is 10 millimeter, right? Or 5 millimeter, whatever it is, but we can control the distance. In the similar manner, let's try with these two assemblies, right? So let's try with these two assemblies. You can see this part is going inside this body. We want to keep it a little bit like a hanging from this body. And for that, first we have to identify the mate that we have applied to place it onto this position. So this is that mate, right? So we'll make a right click and we'll click on edit feature, and we'll add a distance for this mate also by activating this distance tool. And let's add the value of distance 5. So here you can see it's moving. If it is moving in wrong direction, let's say it's moving in inside the body, so that is not right. So we have this option to flip dimensions, right? Either plus or minus. We can by activating this option, we can control the distance, right? Now let's click on finish. So here you can see now it is extended little bit from this one, right? So this is what we got. Again, let's say I also want to lift it up little bit. So in that case, again, we have to figure out that mate. So that mate was this one where faces was aligning. And if I want to lift this piece little bit upward, I will edit this mate, edit feature, right? And we'll activate the distance, and let's add some distance, let's say 5. So you can see it's lifting, right? So that way you can change or control the multiple components or paths inside an assembly file. Here you can see that. This is how you can do, right? Any questions up to this point, guys? Anyone? I will also save it, and all the time it will get saved as a .sldasm. And whenever you will be sharing your assembly file with anyone, you cannot simply save it and share it, because this assembly file is connected with 3 components also, right? And those components are part 1, part 2, part 3. So whenever you are sharing any assembly file with anyone, don't just save this file and share it. That will go with the only the empty information where these 3 parts will be missing, and your assembly file will give an error. So how you can share your file? Simply go onto the file, and there you will find an option that says pack and go. So the moment you will click on pack and go for your assembly file, here you can see it is saving all the things, 3 parts and also an assembly file, and it will create a simple folder for you that will be zipped folder, or whatever you call it, compressed folder. And then right now it will save onto this location. You can see in the assembly folder. So if you click on save, I will click on yes, 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 and it just got saved. So if you go onto my folder now, onto my desktop in the assembly file, okay, so I cannot see it. Let me try again. We'll go onto the file, we'll click on pack and go, and we'll notice the error. We'll click on save. Yeah, first we'll turn on this option, save as zip file. Then only it will zip the file, like compress the file. Now if we'll click on save, you can see it just got saved. And now if we'll go on to that folder, and we'll see, here you can see this is the zip file that you can share with anyone. So if you'll share this file, it will go with all the information like the assembly file and all the 3 files. Yes, Aman, pack and go. So this is how you can share your assembly file. Now until this point, anyone have any questions? Just let me know. Just write into the chat box if anyone have any questions. No. No questions. Okay. So now let's say I will delete these first three. Okay. So now this part is free to move, right? Because we have deleted all the mates. Now let's say I want to mate this part with respect to the center of the body, not onto this slot. How we can do that? So for that, there is this simple thing. Just by pressing shift on the keyboard, select these two faces, right, of your body and these two faces of your body. Like, so I have selected 4 faces, you can see. And now if I'll activate the mate, it will automatically bring it onto the midpoint of it, onto the center. Here you can see like this. So first 2 faces for this part and next 2 faces for this part, right? And the color, you can notice over here, the pink is for this one and the blue is for this one. And what constraint is applied over here is width constraint, where this part is centered, right? So we can change it, like we can also put the dimensions, right? If I want to put or control dimension of this part from this face, we can do that. But here I will keep it centered. I will place OK. So now this part is constrained at the center of the body. So if I'll show you from the top, you can see I cannot move it left or right. It is always centered with the body. It looks like this because it's floating in the space, right? So that is also one thing. Just give me a second. Let me bring it back. Yeah. Now I will click on edit part. Just give me a second. Now if you remember, when we have applied these mates between these two parts, these were rotating inside, right? These were rotating inside. Now what if we don't want this kind of rotation? We want it to be rigid. We don't want this to rotate. So how we can do that? So first find that constraint. So basically the concentric constraint is responsible for this kind of rotation, right? So find that constraint, make a right click on edit feature, right? And then from standard panel, move to the mechanical panel. And inside mechanical panel, right now concentric is applied. So if we'll change this to some fixed kind of mechanism, so I cannot find the fixed mechanism over here. So we'll go back to advanced. Again, advanced also, we don't have that. Slot, no slot, we don't have that. Universal joint, I think should work. Yes, universal joint is to make the rigid. So what I did, I had selected that constraint, the mate, make a right click on edit. And if you want to make it rigid, simply go into the mechanical option and activate this universal joint, right? And once you will apply the universal joint between the mates, you can see the concentric change to universal joint and it will not rotate further, right? So this is also a way to fix your components, right? Now, so this is how you can create your assemblies inside SolidWorks. I think the basic assemblies, let's try that into the part that we have created from the beginning of this complete bootcamp. Let me open the base part. That was the main body part, if you remember. So this is the main body part we have designed, and we have also designed its next part that is going to fit onto this area. So let's start a new assembly file, right? Let's start a new assembly file. So we have started a new assembly file. First we'll save it and then we'll make sure that the units are correct. Now first we'll insert the first component, and the first component definitely will be that main body that we have created, right? So I will enter this, insert this main body into this part like this, there you can see. And before placing, I will turn on the origins, both the origins, and then I will place it just by moving my cursor onto that origin, and here you can see. So we have placed the first component. We'll make it fixed so it is not floating around the space, right? Now we'll insert the next component that we designed for this front area, that is the holder, we can say. So we'll go on to the insert component again. We'll go for the browse option and we'll find that holder part, right? I will click on open. So this is the, I will click on rebuild. So this is the part that is going to fit onto this. And now you can see the orientation is already right. So we don't have to need to rotate this part in any of the axis, right? So I will simply place it near to this part, right? And still it is free. We can move it and adjust it, but that we can also do using the assembly tool, right? Now let's match this part with this piece. So first what I will do, I will make sure that this face, right, this face is touching this face, right? So first I will go on to the mate, will activate this mate tool, will select this face, and will also select this face. So you can see that those got moved and this mate got applied. I will click on finish. So now that tool we applied, so we can still move it like this, right? But the things are not aligned. Here you can see, if you'll notice, these things are not aligned, right? So for that, what we'll do, we'll select all these 4 faces like this, 1, 2, 3, and 4, and again we'll apply the mate constraint, right? And the moment we applied, you can see it just got adjusted completely at the center. Now if I click on finish, so here you can see it just got aligned completely at the center. Now we can only move it along the center, right? And again, there is a small problem. So while designing these 2 parts to fit together, I kept a small clearance between this face, that the first face we applied, this face, this flat face, and the face of this part, right? So when we applied the assembly over here, if I remember, when we applied the assembly, just give me a second. So when we applied the mate in the first part, we had not applied any clearance. So we'll edit this part, right? We'll edit this part, and here we'll add a clearance distance of 0.4 millimeter that we have applied. Like this. Here you can see the part just moved a little bit towards upward. And now that is right. I will click on finish, and here you can see. So this is how the 2 parts are going to fit mate like this. So this is how you can start creating the assembly. So I think for this one, this is okay. So I will simply click on finish. So this is the 2 part we just finished. I will turn off the origins also, so I cannot see those blue dots onto my screen. Now let's bring on the next part, that is the screws, right? That will go from this region. I will again go on to the assembly tool panel. We'll click on this insert component, click on browse. I will find that screw, main screw, right? I will click on open, and here is this screw. So this screw will go on to the bottom threaded hole. So I will first place it because the orientation is correct. Now the next thing is that, just give me a second, guys. Okay, so now the next thing is that we have to align it with respect to this hole. So for that, what we'll do, we'll click on the mate tool, right? We'll click on any cylindrical face, like let's say this face is cylindrical, so I will select that. And then inside hole, we also have to find any cylindrical circle, right? So let's select this circle, but here you can see, because we have created the thread, we are not able to select the exact circles. Here you can see that is the problem, right? And how we can solve that issue? And that issue is very simple. Simply go back to your main body folder, right? And if you'll expand the main body, okay, so I think we have inserted a wrong main body. That's why we are facing this issue. Anyway, let's try that. First, we'll make this using this face. First, I will make sure that this face and this face is mating with each other like this. So whenever the screw is fully tight, it will go something like this, right? I will click on finish. Now we want both threads to be concentric. So we'll select the thread circle and then this circle, not that one. We have to select any one circle, maybe this one. So we have to find, just give me a second. Activate the mate tool, select a circular portion or maybe circular face. I think that should work. And also circular face on this one. Here it is. You can see both of them just got aligned. If I'll click on finish, here it is. Now I can also rotate this screw onto this place like this. Here you can see. So what we did, we had inserted all the three components. We have inserted this screw and applied two mates to make it fix with respect to this body. And the first mate was we had applied this phase constraint between these two faces. Here you can see whenever I am selecting, it's getting highlighted. And then we applied a concentric constraint between the threads of the two things, that is one for the screw and one for the whole of the threaded area. And because of that, both of them just got aligned with respect to each other. So this is how you can define. Now let's say I don't want this screw to be fully tight. I want to sew it just half tight, right? I want to place it little bit away from this face. So that we can do simply go into the mates, find that coincident constraint, make a right click, edit it, and then activate your distance constraint and add some distance. Let's say 10. So you can see it just got moved. I will click on finish. I want to show it like this inside the assembly, right? So this is how you can keep adding components, multiple components inside your SolidWorks assembly. So let me know any questions up to this point. Anyone? I'm waiting for your yes or no into the chat box. All participants. And again, I'm repeating, all these recordings will be available into the dashboard itself. Yes, the drawing parts will be covering on the next session, that is tomorrow, how we can start getting drawings from these assemblies. So the drawings will be covering tomorrow. So please join the session tomorrow to get all the details about like how we can start creating the manufacturing drawings from your SolidWorks assembly or using your SolidWorks part files. So the tomorrow session is also very important. Please be on time. Please be ready with all the questions you have. So this was all about the SolidWorks assembly that I had planned for today to talk about, to discuss about. Now, if you have any questions, just let me know into the chat box. Just write into the chat box any questions about SolidWorks, part files, assembly, design. Let me know. Just write into the chat box. I'm waiting for your questions. So now we are taking questions. Just write your questions into the chat box. Every one of you, please ask questions. Okay, so you are asking for
I
the
have one
drawing.
question, sir.
Yes, yes.
Sir, customer side one model drawing you give me, sir. One part CAD model 1 point give me, sir. So 1.2% increase the dimension value. How to this? Every dimension 1.2 value enter the model, sir. Totally increase of 1.2%.
So
How this
here
is possible, sir?
I got it. So here two things. Like see how the customer wants. The first thing is, for example, let me open a part file for you to give a example. So let's say if you have a part file, right? And if someone asks me to increase all the dimensions by 20%, so that will be 1.2, right? So if someone asks me to increase the dimension by 20%, and if he also need the SolidWorks file where he can check the dimensions, whether we have increased the dimension or not. In that case, you have to change all the sketches, right? And accordingly, you have to increase all the feature sizes. Otherwise, the next way to do this is simply you can see a solid body into your design tree, right? Then you have to find a tool called scale. Can you see this tool called scale? Just keep it this tool, scale. Now what a scale does, you can directly scale your solid model into the SolidWorks without affecting the older design history. So what I will do, I will activate the scale tool, right? I will select the body. I will change this to 1.2, right? I will place it, will click on finish. You can see the body just got scaled up, right? And for this hole, if we'll measure, here you can see right now it's 9.6. But if you remember, we had only took that hole into the sketch history. If we'll check, let me check into the sketch history. Hole, this one, right? So in the sketch history, not this one, this one, yeah. In the sketch history, if we'll check, it is still, the hole is still 8 mm, right? In radius 16. But the moment it this history reaches after this scale, right now this, here you can see everything is 1:1 scale. But once we have applied this command called scale, everything is scaled up by 1.2%. Right. So this is one way to scale your everything like design, and then you can create a drawing from this, right? So once you have scaled that model, you can create a detailed drawing from this that will be 1.2 times, right? Because drawings are always created for the final model into your drawing. But if you create a drawing at this stage, when all the things was smaller, you will get different dimensions, like the actual dimensions that we have used. And what if you'll create a drawing after this step, so everything will be 1.2% enlarged. I hope it's clear to you.
Okay, sir, I understand. Thank you, sir.
Yeah. Otherwise, it's super tough to change all the dimensions by 1.2%. You will have lots of errors into your drawing. Like if you'll change the first sketch, the rest of all the things will start showing you the error, and that will be super complex if you have multiple parts or assemblies in an assembly. So the best way always is to use the scale command. Okay, so anyone, okay, so the Naidu is asking for the drawings, how to get access. I mean, for the parts we have inserted, did we able to get, no, for drawings, the access are completely different. There is nothing to do with the, like how we keep our accesses in the part. So just forget about that. When you will create drawing from a part, you can define different access style, because that is about creating a, what will say, it's a sketch kind of thing. Creating a drawing is kind of a sketch. So we can do as per our choice. So anyone else have any questions? Just let me know into the chat box.
Sir, I mean, when we insert the screw into the hole, we take the circle, right?
Yes.
Instead of circle, what if we take the center point of that circle and the screws center point?
Yes,
That
yes,
is
it's
what I'm
possible.
asking.
Like we can, instead of selecting the faces, we can even select the entities, and we can apply the relation between them. Because what we are doing,
Yes, sir.
when we are selecting multiple cylindrical faces, we are applying a concentric constraint, right? So that means
Yes, sir.
we are trying to make two pieces at a same center, right? This is what
Yes,
we are
sir.
trying to do. But we can also do with the sketch. For example, let me show you. For example, in this case, let's forget about the main body at this moment.
Yes, sir.
And let me delete all these things. So indeed, in this case, let's say I want to place this piece with respect to this one, right? So first what I will do, first I will turn on the sketch for this thread we have created. So we'll go on to the holder and we'll find that sketch. Yeah, this was the sketch. So right now you can see this sketch is visible, right? The center point of that sketch. Now let's say I want to apply that constraint with respect to that point. So the first thing that we'll do, we'll go on to the mate, right? We'll first align this face with this face, something like this, right? I will click on finish. Now again I will select cylindrical face, like this face, and will, instead of selecting any other face, I will select the center point. You can see that, right? And okay, so it's giving some error. So let's solve this. So what we'll do, you can see the sketch for this is active. We'll also activate the sketch for this one. So we'll go on to the screw option. and we'll turn on the sketch as well. Where is the sketch? Yeah, this is sketch. Let's turn it on. Right. So you can see we have both the sketches, right, for this one and this one also. Right. Or else what we can do, we can simply activate the mate tool. We can select this cylindrical face and we can select this center point that we created. And why we are getting this problem is because we have to apply the concentric, not coincident. There you can see. So both of them just got aligned. So we can select bodies and sketches also. That's not a thing. For example, we did something like this. Let's delete these mates as well again. Now you can see both of them are free to move. Now let's say I want to mate this face using this corner point. So I can do that, right? And that will be aligned with that corner point all the time. Here both the bodies are floating. That's why you can see whenever I try to move, everything is moving inside the screen. That's why I say always keep at least the first component, base component, as a fixed one. Right. So we have options. We can apply assemblies. We can apply mates between sketch, body, sketch, body, all possible.
Sir, and also at the center point, do we able to get center line?
So why do you need center line? Tell me, why do you need center line? We can get that. And for that, what you have to do, go back to your model, click on edit part, right? So first what I will do, just give me a second. I will go to the body and click on edit part, and what it is saying, okay, it has not been saved. So first we have to save it. We will then save. Yes, we can get that access. I will show you how. Okay, so I will go on to the body and we'll make a click on this edit part, and here you can see now we are editing this part, and you want to have an axis right onto this hole. So for that there is a tool called inside reference geometry. You can see this axis tool, right? That you can find under the features tab. Go to the reference geometry, activate this axis tool, then only select the cylindrical face and click on finish, and you can see the axis just got created, right? So by using that axis also you can, this is the axis. So by using that axis also you can start defining the assembly or mates, right? Because this axis is also kind of entity inside SolidWorks, and you can find that inside your design tree as well for this particular part. So we'll come out of that part. You can see the axis is right now turned off, make it visible. So you can see the axis should be visible. Okay, so the axis will only be visible once you will move your cursor onto its top. Right, like this. So yes, we can do that. Any more questions? Anyone?
Thank you, sir. Thank you.
Thank you.
I have one more question, sir.
Yes.
Sir, any moving part of simulation will the software creative is possible, sir?
Yes, definitely. We can create the advanced mates where we can have the control, like how much we want to move. For example, press Ctrl Z. For example, okay, let me close this one. Let me open our assembly file that we already created. For example, in this case, I want to make sure that this part should not go beyond this face. Here you can see it's going inside, right? And also it should not go away from this face, but it is still going away, right? So we can you hear me?
Yes, sir.
So we have that options to define the distance between the constraints, and that we can do under the advanced mates. So if you remember, for this one, for this, okay, between these two parts, which is the constraint, first we have to find the constraint that we have applied between these two parts. So once we'll find that part, go on to the edit feature, and then then we have to define inside standard, we have to define the distance, not distance, we have to define inside mechanical, I think. Yes, inside mechanical, we have to define what kind of movements we need for a particular mate. So in this mate, there is no, these options are not available. But let's say if you have defined slot mechanism where one body is moving inside a slot, so you can activate that and you can define the distances. So that I will be showing you tomorrow, because drawings will not take too much of time. So I will show you how we can do the advanced mates where we can control the distance. Like even if the mates are applied, we cannot move beyond that part. So that will be doing it tomorrow. And simulation, that like animation kind of thing, I will not be able to show you because for that you need a SolidWorks full license to create SolidWorks simulation. Yes, that can be done definitely inside SolidWorks, but my PC is not that much strong to handle the simulation part because it takes so much power and processing. Clear?
Yes, sir. Yes, sir.
More questions, guys? Anyone?
Sir.
Hello? Unmute yourself. Sorry, unmute yourself and then you can ask.
Sir,
Yes.
advanced version only possible of the animation, sir. Old version not possible, sir.
Sorry?
Sir, the simulation for advanced version only possible. Old
No,
version
it's
not possible,
possible
sir.
in any version of SolidWorks, but for that you'll need an advanced PC. Your PC should handle that motion study. So it's called basically a motion study. And that tool you can find inside the assembly panel itself. And onto the top, you can you see this new motion study? Can you see this tool, new motion study? So by using this tool, new motion study, you can animate the movements of your part with respect to other part, right? So it's kind of recording each frame of motion in each seconds, and then you can animate it, right? So that's basically like a kind of video editing kind of thing, like, or kind of creating any animation, kind of any animation software. So for that you have to understand a little bit, uh, have knowledge about like the keyframes and the stuff like that. So that we are not going to cover into these boot camps because these are all very advanced things. But still, I will share some videos link into the WhatsApp group. If you want to explore, you can check that out. They are very detailed video, very well explained.
Thank you, sir.
Thank you. Anyone else have any questions? We can close this session now because we are already running out of time.